much. Yep, that should be in there. Okay, so I'll just start off with tracing basics, because even people who have already done tracing don't know some things. So basically you've got an app and you want to observe it. And what you do is you plug in an agent, and it's minus Java agent, or there's also auto instrumentation in Kubernetes, which I'm going to use because it's more convenient. Now, what the agent does is it instruments technologies. Okay, so some people think the agent looks at everything the application does, and instruments everything. It doesn't. It instruments very specific technologies. They're the technologies, the frameworks that people mostly use, but that's not every technology. So you can have stuff that's in your application that's not observed. So here's an example. I've got actually 4 servers here. And the application is sending a request, server 2, which goes on to server 4, and also another one to server 1, which goes on to server 3. And you can see with server 2 and 4, you can see the full waterfall. You can see the request in green going to server 2 in blue, and then server 4 in 4. That's the top one. The bottom one, it's exactly the same scenario, but server 1 and server 3 are using technologies that aren't instrumented. And so you don't see them. Okay, so it's just something you should be aware of when you're doing tracing, that not everything is automatically instrumented. And one of the things that we have is this thing called inferred spans. That's technology that was made at Elastic by one of my colleagues, Felix Barnsteiner, and we contributed it to the OpenTelemetry system. And they're very happy with it. So all the stuff that I'm talking about is in OpenTelemetry here. It's available in OpenTelemetry. It's already included in our agent, in our EDOT agent. And so what this one does is it runs a profiler alongside the tracing. So if you think about it, the agent instruments certain technologies. For example, your web service, the HTML, the HTTP server that's in the web service. If you're using Jetty, it's instrumenting that. It's looking for requests that come in, and it will create a span around that request. But for other technologies that aren't being instrumented, if you're running with inferred spans, it runs a profiler alongside, and it looks at certain threads, the threads that your spans are working with, and it sees what they're doing, and then it says, okay, this method here has been running for a while, but it's not instrumented, so let's just create a span for it. So it's a brilliant combination of profiling and tracing. So I've got a demo. Let me go into, what have I got here? So I'm running Kubernetes. For those of you who know Kubernetes, this is just done a get pods, everything. It's running just the core Kubernetes system, and it's got the OpenTelemetry operator, which is the thing that it mainly needs. So let me just kick off my example. So what I'm going to do is just, oops, that's the wrong one. Let me go into here. I'm in the right directory, okay. And I'm just going to show you the application that I'm using. So there's this application, it's in a blog we wrote. It's a really simple, stupid application. It just loops. You don't need to know Java to see. I don't know where my cursor's gone. Hello, cursor. It's disappeared. Okay. Well, you can see that it's just it's a loop there. At the top, there's a run, there's a loop, and every 2 seconds, that's thread.sleep 2,000 millis. Every 2 seconds it loops. It calls method A calls method B calls method C calls method D. The only things is that method and C and D print out that they're being executed. And method C sleeps for, 10 milliseconds. Method D sleeps for 200 milliseconds. So it's a very simple application. And what we've done is, let me show you, we have put that into an image. So you've got the image here. Oh, there's my cursor back. This is an image that's available, and we just keep that available for running tests. It's quite handy. So all this pod is doing, if you're not familiar with YAML, it's just it's just a pod that's running in Kubernetes, and essentially it's just running this image, which is in turn just running that application that we just saw. So if I have a look at the logs here, then you can see it's just printing out method D, method C, method D, right from the beginning, executed. It's doing that every 2 seconds. So far, we're just running an application. We haven't instrumented anything. So let me kill that off and start example 2. So the difference here, I'm going to show you the diff between the example 1 and the example 2 YAML. Ignore the new lines bits. It's just added an annotation. So literally no code changes, nothing changed. All I've done is added a single annotation into the description of how to run the application. And that's all it needs, and it's tracing. You'll see that in a second. I'll just explain this. This bit here is telling the OpenTelemetry operator that you want to install something into this deployment. This bit here is saying, I want to install a Java type something or other. This bit here is telling me it's in a Kubernetes namespace called Elasticon, and this bit here is the actual name of the instrumentation. So that's just defined in another file. It's just an instrumentation. It's a description there. So if I look at the logs, it looks the same, but if we go up to the top there, you can see it's actually slightly different, is that it's installed the agent. So we've got an agent running. This is running version 1.2.1, which is the latest version of our EDOT Java agent. And if I go over to, let's go over to observability. This is the service, the list of services. There we go, there's example 2. And it's actually quite not very interesting because there's not much happening. We do have some metrics in there, but there's nothing in the way of traces. So you can see some metrics coming through, but there's nothing in the way of traces. And that's because, as I told you in the earlier thing when I was talking about tracing, not all instrumentations, not all technologies are instrumented. And if you think about this very simple application that I'm running, there's no technology in there that it knows how to instrument. Now, all agents have a workaround, not really a workaround, it's a feature. Let me just stop that and start example 3. And then I'll show you the diff here. There's a feature here. So all I've done is added in an environment variable, which is OTel instrument methods include. This is a standard feature of the OpenTelemetry agent, and of course the Elastic EDOT agent, because that's the distribution of the OpenTelemetry agent. And it just says, I want to trace also this method. And I've just chosen method B for it to trace. So you can actually put any methods you want into there. It takes a list of methods. I think it's semicolon, comma separator, I can't remember, one or the other. But you can put dozens of methods in there. I've just put this one in there. So if I have a look now at let's go back to the service inventory, and we've got example 3 running now. And now the transaction's a bit more interesting. We actually see a trace, and it's tracing there. So tracing method B. But still, I mean, it's better than nothing. So we've got some data. If we could look at some interesting data for method B, but there's nothing more. It doesn't tell me anything more about the application. And this is this is where inferred spans come in. So that's exactly the sort of thing where you have applications where things are using technologies that aren't instrumented. So this is again the diff between the last one and this one, application 4 that I'm running. So what I've added is just turning on OTel inferred spans. And again, if you see the name is OTel inferred spans, so it's a standard OTel capability. It's part of the OTel contribution because we contributed it. It's not installed with the agent. It's installed automatically with our agent, Elastic EDOT agent. But you can actually install it, and I'll show you how very easy it is to add it in to the vanilla, the upstream OpenTelemetry agent if you wanted to. So all I've done is I've turned on inferred spans. So now if I go back to here and look at the service inventory, we've got example 4. Didn't take, okay. Let's go in. We've still got testing method B. That's still the only thing we're instrumenting. And then what we've got here is an inferred span. So you can see it's got a different label here. It's internal. I don't know if that's clear. I'll make it bigger. It's an internal mechanism. So the first one's example 4 app, but the other one is an internal one. And if we go along, so what's happening here is that it's running a profiler alongside, and it's seeing the stack trace, and it's seeing that method D is taking a lot of time, but there's no span for it, so it's going to create a span for it. And what's happening is that it's doing a stack trace every 50 milliseconds. If you remember, method D was a 200 millisecond one. So every 50 milliseconds means it has to approximate the time there. So this is 150 milliseconds. It's just approximating. And if we go along here for a few of them, it might also catch method C. Because if you think about method C, although it's 10 milliseconds, it's calling method D, which is another 200 milliseconds. So method C is actually running for 210 milliseconds. So there is a possibility that you can catch it in a couple of stack traces. It needs at least 2 stack traces to make an inferred span. So at the beginning and the end, just between method D. So this one caught that. So it's increased visibility. And you get it for free, essentially. It's a very low overhead. It's underlying, it's using Async Profiler, which is a very low overhead profiler within Java, and it's safe to use in production. Lots and lots of people use it. Async Profiler itself in production, and we have a lot of customers who use inferred spans in production. So let me go and kill this one. And then I'm just going to show you one more thing here, which is, I'll show you the diff. So the difference this time is that I've changed the instructions for the operator to install. And I was, remember, I was installing that's the Elastic OTel. So I was telling the operator to install our EDOT agent, the Elastic EDOT agent. Now what I've done is I've told it to install the vanilla agent, but with extensions. So you can set up your configuration, your instrumentation. I could, if I do a dir here, you can see it's this one here. If you're particularly interested, then what it's done is it's an instrumentation. And it's saying, okay, I want to use the pure plain OpenTelemetry instrumentation, but I also want these extensions. And these extensions are the ones that are in the contrib repo. Let me just go and show you here. We've got, this is the repository that I'm talking about here. So this is up here, you've got the OpenTelemetry contrib. They're all in the contrib repo here. And what we do, what Elastic does is, because we build them automatically for our EDOT agent, we also build them separately as an extension and plug it into our Docker image so that you can use it in this way. So very specifically, it's designed so that if you want to run your OpenTelemetry agent, just the upstream one, you can add in the extensions. You can also do it yourself. You can build it yourself from the contrib repo here and install it yourself. So that's what I've done. And if I go over here back to the service inventory on example 5, you'll see the same as we did with the last one, because this is exactly the same, almost exactly the same thing as our EDOT agent. This is just the upstream OpenTelemetry agent running with the inferred spans contribution and yeah, so it's like very similar. Our EDOT agent has a few more capabilities. There's a few more things we put in there. There's some dynamic capabilities that you don't have in the upstream agent yet. We do contribute everything. We tried to contribute everything upstream, but you get some stuff in the EDOT agent first. And just got time. There is I'll leave it for the moment. So I mean, you can use. We also have our classic APM agent, and you can actually use the same mechanism to install the classic APM agent into your system in Kubernetes. So I've got a demo if you're desperate for that later. Okay, so that was inferred spans. That's one contribution, one extension, OpenTelemetry extension that you can run with your agent. And again, you get it automatically with the EDOT agent, but you can include it with just the OpenTelemetry agent very straightforwardly. I'm just going to flip over to the eBPF profiling. I'm not going to demo this. With Elastic, you get it as universal profiling. We contributed the whole of that to OpenTelemetry, but of course ours is production capable already and has been for a while. The OpenTelemetry one, although we contributed a while, it's taking them a bit of time to develop it. So it's not really production ready for the OpenTelemetry version. So right now you can use it with Elastic. Probably about a year's time it will take before it's production ready in just plain OpenTelemetry. So think about the inferred spans. That example we had, it was just sleeping. That method D was just sleeping for 200 milliseconds. So it wasn't a CPU. It was a blocked method. eBPF profiling currently is only CPU profiling. So it only sees things that are on the CPU. So for example, that method D and that method C, because they're sleeping, wouldn't be on the CPU. You wouldn't see it in eBPF profiling. So they're complementary kind of technology. The inferred spans gives you it gives you visibility also into CPU profiling, because if it's spending a lot of time in the system running, then the profiling will take it, but they're kind of complementary. This gives you a much more system-wide view, but it is CPU-based profiling. There is no fundamental limitation. It can do profiling of waiting threads as well, but it doesn't at the moment. That is something that will come along, but it will take time. And it's fantastic. I don't know if you've ever used it, but eBPF profiling, the universal profiling in Elastic, is just tremendous visibility into your system-wide, not just within one application. And we have the technology that associates it with applications, so you can go from a trace to the profile and from a profile to a trace, and it works really nicely. Okay, so this is another contribution that we gave to the OpenTelemetry agent. Again, it's in that contrib repo, and it's span stack traces. So this, it sounds very straightforward and simple. We just take a stack trace for a span. If the span has run for more than, I think it's default of 5 milliseconds here there. But the funny thing is that that wasn't there, and it is there now. And if I go here and I show you here, you've got that's the stack trace there. It's phenomenally useful. It's just like you start investigating your system and you see these spans are taking problematic times, and then but all you've got is the name of the span. Without that stack trace, you've got the name. And you have an idea of what technology it went into, but you'd have to search through your code base. Here it gives you immediately where it was in your code base. So it's just a very simple thing to add, but it's very, very effective. So that's one of the things that, again, another thing that we've contributed, and very useful and very simple to include into the agent running. Okay, so I think we are at the point where we want to take questions. Now, I do have, just before that, I have another demo which will take time, so I'm not going to do it. There's a little bit about me. I'm going to stay on this, and then if there aren't enough questions, I'll do that demo at the end. So we'll take questions now, if there are any.
If you have any questions, just wave at me and I'll run at you with a microphone. Cool, going over there.
Dalio. So you say low overhead profiler for Java. Obviously, we'll be looking at profiling stuff other than Java. And also for Java, when you say low overhead, what does that actually mean in terms of, like, if I'm doing, like, 10K lines of bytecode per second, right? How much more or less am I actually going to achieve if I have profiling enabled, right? When we're looking at high intensity applications. eBPF is more understandable from like what sort of throughput changes you're going to get, but with a profiler alongside it, what does low overhead mean in that case, and how does it apply to like other languages and
So both eBPF and the async profiler are sampling-based profilers, which means that you can control exactly the frequency of the samples, so you can reduce or increase the frequency. And typically sampling-based profilers, if they're doing it efficiently, which async profiler does, add maybe 1% overhead. Obviously, if you increase the frequency, that'll increase. If you decrease the frequency, that'll decrease. But typically 1%, maybe 2% overhead. I don't see any hands raised. So.
Yeah, any other questions?
Oh, there is one over here.
I'm coming to you.
So we use Elastic APM in our organization. I was asking, what does this give us compared to Elastic APM?
Well, this is part of Elastic APM.
So we will keep using the same SDK and then just enable?
Actually, currently you're probably using the classic agent, which also has inferred spans, because as I told you, that was technology that was developed at Elastic. So we have it in our classic agent. And if you want to move over to the EDOT agent, the OpenTelemetry agent, then that's there as well. Is there a reason for moving over to the EDOT agent? At the moment, it's just if you want your organization to move towards OpenTelemetry. Ultimately, it'll have more features than the classic agent does. But currently, if you're just running existing APM, it's only if you really want to be an OpenTelemetry shop that you want to move over towards the EDOT agent.
And does it cover logs as well?
Yes.
So OpenTelemetry does give me the same power that, for example, Logstash gives in order to process logs and add some processing customization.
The OpenTelemetry logs, it's not quite as well developed, and we, again, Elastic are leading that contribution to make sure that it gets up to speed and is more capable and more like Elastic and Logstash.
Yeah, I guess to caveat as well as with my JavaScript hat on, it does also depend on the language, because OTel Java is obviously very well evolved for logs. But for example, if you're using the JavaScript agent, logs are currently still under development, so just watch that in the documentation as well. Does that make sense? Cool. I have time for one more question. Right, I'm coming to yourself over there.
Hello. We have Java applications running on Kubernetes, but we also have Java applications on AWS Lambda, and I wondered how applicable some of the stuff you've spoken about is to AWS Lambda, and if we can use it in a similar way.
So our Java agent runs in AWS Lambda. You have to install it in a different way. It's not auto-instrumented. You have to set a bunch of environment variables. But otherwise, it's got all the same capabilities, all the same technology. It's exactly the same agent.
So is that the Elastic agent, or is that
currently it's the Elastic APM agent, the classic agent. The EDOT agent runs everywhere, but we haven't actually tested it yet in AWS Lambda. So we're not sure. I wouldn't say that's something that I would immediately try. But we will be doing that. We are going to make sure that it runs in AWS Lambda. But at the moment, it's the classic agent.
Thank you.